Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Right, sequence and series 2020 question. It was a long one. It was question 7 for 50 marks. So a number of the form 1 plus 2 plus 3 plus ... plus n is sometimes called a triangular number because it can be represented as an equilateral triangle. The diagram below shows the first 3 terms in the sequence of triangular numbers. So we have T1 equal to 1 dot. T2, we have a row of 1 and a row of 2, so T2 is 3. Then we have a row of 1, row of 2, row of 3, so T3 is 6. T4, 2, 3, 4, so I need to add 4 onto 6 to give me 10. Now, really reduce him down. Okay, so that's T4. T5. I need to add on 5. T6, I'm going to add on 6. Okay, because you can see the pattern that's been established now. I'm just literally adding on the next row of dots where the row goes up by 1 number every time. 2, 3, 4, 5, 6. So that will give me 21. For T6. T7, I'm going to add on 7, so it's going to be 28. And T8, I'm going to add on 8, so it's going to be 36. Okay, so I hope that makes sense. Don't overthink this. If you're asked to fill in a table or you're asked to draw the next pattern, try not to overthink it. It can be relatively easy. There was 10 marks out of the 50 for just this part. So it's a really nice start to the patterns question if it comes up. So take it and enjoy it. Okay, so the nth triangular number, this is part 2, the nth triangular number can be found directly using the formula Tn is equal to n times n plus 1 all over 2. Is 1275 a triangular number? Give a reason for your answer. Okay, so they haven't given us a specific term to figure out how many dots is in it, okay, but they've instead given us an answer and they've asked, does that correspond to a triangular number? So what they're saying is, if we take our formula for Tn and we let that equal to 1275, is there a value for n or values for n that satisfies this equation? Okay, if this holds true in that we get a perfectly round number for n, then 1275 is a triangular number. If we get a decimal point for n, then it's not a triangular number. Okay, so let's see, I think I'd multiply across by 2 so that I get n times n plus 1 being equal to 2550. Okay, going to multiply out the left, so n squared plus n. I'm also going to bring him over because I can see the quadratic forming is equal to 0. Okay, so I'm going to use the minus b formula. A is equal to 1, b is equal to 1, c is equal to minus 2550. Okay, so x, or n in this case, because n is the letter in the question, n is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so come up here. So it's equal to minus 1 plus or minus the square root of 1 squared minus 4ac all over 2 times 1. So I'm just putting the square root bit into the calculator. So square root of 1 squared minus 4 AC. And I got 101 for that over 2 ones are 2. Okay, so let's split that into the plus and the minus. And we're going to get minus 1 plus 101 all over 2. And I get n is equal to 50. Let me go back and change that plus to a minus. And I'll get n is equal to minus 51. Okay, I'll discard the n is equal to minus 51 because you can't have a negative term in a sequence. So n is equal to 50. Therefore, 1275 is a triangular number. Okay, I hope that was okay. So there was 5 marks for that. B, part 1. The n plus 1th triangular number can be written as Tn plus 1, okay? And hopefully that makes sense from our theory, okay? It's 1 up from the nth number, so it's Tn plus 1. So it's equal to n plus 1, and of course I add on n plus 1. Because remember when it was T7 here, I was adding on 7. When it was T8, I was adding on 8. Okay, so what you're doing is whatever term you're getting, you're adding on that number. Now, you didn't have to fully understand that to be able to do this question, but if you can see it, that's even better. So write the expression n times n plus 1 all over 2 plus n plus 1 as a single fraction in its simplest form. Well, as it turns out, this isn't really a sequence and series type question. It's more a fractions question. So I have to basically simplify this fraction. Okay, so as with any other fraction, we get a common denominator. So my common denominator is going to be 2. Okay, so let's multiply everything by 2. Plus 2 times n plus 1. Okay, cancels. So that you get n times n plus 1 plus 2 times n plus 1 over 2. Okay, and that's just one way to do common denominators. It's kind of a longer way that tends to be quite popular in school at the moment. Of course, you can always put this over 1 and go 1 into 2 goes twice everything on top. Okay, you're going to get the same answer. So however you do fractions, however you get a common denominator, do it that way. Okay, let's multiply this dude out. So I get n squared plus n plus 2n plus 2 all over 2. Okay, so I'm getting n squared plus 3n plus 2 all over 2. Write it as a single fraction in its simplest form. Okay, this looks like it'll factorize. So let's do that. N and n, 2 and 1, plus and plus, all over 2. Okay, so I hope that's okay. There was 5 marks again for that. So not really a sequence and series type question, more of a fractiony algebra type question. Part 2 then said, prove that the sum of any 2 consecutive, and consecutive means one after the other, consecutive triangular numbers will always be a square number. Or in other words, a number in the form k squared, okay? Now, these type of questions take a bit of getting used to, okay? Because when you read this, will always be a square number. I would expect for the majority of people that will make no sense at all and will quite scare you into not starting the question in the first place because you don't know what it means, okay? And that will happen more times than you care to think about on a higher level paper in the Even Cert. And my advice to you is not to be too put off as to what format the answer will take or proving that it's a square number. Try and do what they ask you to do in the question and just see then when you get to an answer, can you make more sense out of this? Okay, so it says prove that the sum means add. and any two consecutive triangular numbers. Okay, so any two consecutive numbers, remember we had Tn plus 1, and of course before it we had Tn minus 1. Okay, so this is an example of one of those exam questions where I was talking about they could ask you the question quite abstract and you have to make sense out of it. Okay, so I would argue that if you add Tn minus 1 to Tn as such, okay, if you add them together, that would meet this condition, the sum of any two consecutive numbers. Or of course you could add Tn and Tn plus 1 together. Okay, that would work either, and in that way you are proving the case for any consecutive triangular numbers. Okay, and that's the benefit of doing it. That's the benefit of doing it with Tn plus 1, Tn minus 1, rather than going back to the table and trying to do it with two specific terms. Okay, because if you do it with actual terms, then you're only proving it for that case, T1 and T2. If you do it for Tn plus 1, Tn minus 1, you've done it for every single case. Okay, so that's what they're asking you. So I'm looking at my question. I see an expression for Tn, so I'm definitely going to use Tn. Okay, so let me write that one down. Tn is equal to n times n plus 1 over 2. Let me just make sure I took that down right. N times n plus 1 over 2. Okay, so that's the Tn one taken care of. Now I'm trying to see, is there an expression for Tn minus 1 or Tn plus 1? And there is. That's what we did in the last question. So let's use Tn plus 1 in that case. So in the last one, we said Tn plus 1 was equal to, I can't remember what the factors were, n plus 2, n plus 1, all over 2. Okay, if there wasn't an expression for Tn plus 1, of course, you could establish one. Okay, let me show you how I would go about doing that. Or Tn minus 1, it doesn't matter. Okay, everywhere there was n, you would put in n plus 1. So everywhere there's n, you put in n plus 1. There's an n, I put in n plus 1. And you tidy him up, and what you'll do is you'll end up getting this. Okay, so this question was okay in the sense that it kind of led you along the way to this question. Not all questions are that nice. Sometimes you'll have to establish a formula for Tn plus 1 or Tn minus 1. Okay, so prove that the sum of any two consecutive numbers is a square number. Okay, so let's see how we get on with this one. So what I'm doing is I'm doing n times n plus 1 over 2 plus n plus 2 times n plus 1 all over 2. Okay, and I'm trying to see if they're a square number. Okay, what is the easiest way now to do this for ourselves? Okay, so this might take a bit of playing around just to see how far you get. Well, I'm going to stick it all over 2 anyway, because it's all over the same common denominator. What I'm doing is I'm trying to figure out, am I easier multiplying it out now or leaving it as is? So I'm going to multiply it out. So I get n squared plus n, and I'm going to see where it brings me. So this side, well, it's going to be what I factorized, n squared plus 3n plus 2. Okay, so let's tidy him up. I have 2n squared plus 4n plus 2 all over 2. See, did I do that right? 2n squared, yeah. So I'm going to factor out 2 out at the top. Do you see it's common? Always good to factorize, all over 2. The 2's will cancel. Okay, so now I have n squared plus 2n plus 1. Okay, and I don't actually even need the brackets in that. Okay, will we try factorizing him and see what happens? N and n, 1 and 1, plus and plus. Okay, so that is in fact n plus 1 squared. Prove that two consecutive numbers will always be a square number. A number in the form k squared. And I would just put a QED after that, which is just I have it proven. It is a square number, okay? Now, there was no way anywhere along the way down there that I could see how that was going to pop out, okay? So try and do what they ask you to do and hope that you'll get a little bit of inspiration somewhere along the way that'll tell you how they want the answer. Okay, cool. Two consecutive triangular numbers sum to 1, 2, 5, 4, 4. Find the smaller of these two numbers. So two consecutive triangular numbers sum to. Now we have a formula for the sum of two triangular numbers, and it's n plus 1 squared. So that's equal to 1, 2, 5, 4, 4. Okay, and I'll tell you what I'm going to do. I'm going to see if I can get the square root of 1, 2, 5, 4, 4. Ah, that's quite nice. Okay, my thinking is square and square root cancel. So I popped the square root of 1, 2, 5, 4, 4 into the calculator to see did I get a nice round number, and I did indeed get 1, 1, 2. And again, I don't really need the brackets here anymore. Okay, so I hope that makes sense. If that hadn't worked out, okay, so this was my plan B. If that hadn't worked out, of course, I'd have just worked out this on the left, and I'd have formed a quadratic, because you can see I'd end up with an n squared and an n again. So I've ended up forming a quadratic and solving it, and that's a perfectly acceptable way to do it as well. Okay, bring this over. And of course, I get n is equal to 1, 2, 2 minus 1, or n is equal to 1, 1, 1. So two consecutive triangular numbers sum to 1, 2, 5, 4, 4. Okay, find the smaller of these two numbers. Okay, so let's find Tn. What was Tn equal to? N times n plus 1 over 2. So if I need to find T111, it would be 111 times 111 plus 1 over 2. We put him into the calculator, and he is 6216. Okay, just to check that he's the smaller number. Okay, on my calculator, this is what I would do. Okay, so I would find T12, and that would be equal to 112 times 112 plus 1 over 2. And it's 6272. And I would also check T110. So what I'm doing is it told me to find the smaller of these two numbers, and I'm wondering, is T11 the smaller or the larger? Because obviously I have to add two numbers together to give me 12544. So I'm going to check 10 now. And I'm getting 6050. Okay, so 6214 plus 6272. It's 12486. And that doesn't work, as I would expect. Okay, so I'm hoping now the other one works. Oh, that was 112. Neither of them work. Okay, I think I've gone somewhere wrong there when I'm checking it. It's I just do a quick little check just to see I didn't do something silly. I did. I took this number down wrong. So of course they're all going to be wrong. So 6216 plus 6272. I definitely can't multiply this morning. Okay, 6328 plus 6216. 12544. All right, surely one of them had to work, okay? And the one you'd expect to work is not 110, guys. It is T11, T111 plus T112, okay? Because T11 has to be the smaller number. So what I was trying to show you there was find out what T112 is, add these two together, and just convince yourself that the sum of the two consecutive numbers is 12544. Okay, sorry, I messed up my checking part rather than anything else. Okay, and normally this work I would do on a calculator as opposed to write it down in my exam paper, but you can do either. Okay, so that's your answer there, 6216. All right, part C. Some numbers are both triangular and square. For example, 36. So Leonard Euler discovered the following formula for these numbers. N of k is equal to blah, 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 all to be squared, where nk is the kth number that is both triangular and square. Use Euler's formula to find n3, the third number that is both triangular and square. Okay, so the essay could very well put you off this question, okay? But if we come down to what are they asking? And maybe the chat will make sense when you do some of the arithmetic. So the question is asking you to find n3, okay? And we have a formula for nk. So if I'm told to find n3, then isn't it a matter of just replacing k with 3? Okay, so let's try that. I have 3 plus 2 root 2 to the power of 3 minus 3 minus 2 root 2 to the power of 3 all over 4 root 2. Now there's more danger of me putting this into the calculator wrong than anything else. Okay, so let's try this one. So on the top, to round it all, I need a bracket. So try and see, can you get it into the calculator and that you get the right answer. All to be squared minus bracket 3 minus 2 root 2 to be squared, and then on the bottom I have 4 root 2. And then outside all of that, it's all squared again. And I got 1225 for that question. If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice. In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.